Hello students and welcome to Lesson 2 of Unit 5. In this lesson we are going to delve deeper into what relations and functions are, with a specific goal of being able to look at a real-world situation and decide whether it is a relation or a function. So our first essential question is, what are relations and functions? This is going to be key to the next 3 lessons. Our second one is going to be, how are these relations and functions both similar and different? And third, how can I decide if a relationship is a relation or a function? To help you visualize the difference between a relation and a function, I want you to imagine that we're in the classroom, and as students are walking into the classroom, I am handing them a number. Everyone in the classroom can see each other's number. Okay? So here's the people in our classroom. We have Adam, and when he comes in, I hand him a 1, and you can see that he has a 1. Betty has a 2. Kara has a 1. Donnie has a 2. Emily has a 1. And Flora has a 2. Now, these people, these 6 students, stand at the front of the room. And you, as the students in the class, and I are going to play a guessing game. So we're going to play the guessing game 2 ways to see if you can win. So let's play way 1. I'm going to tell you someone's name, and you have to tell me their number. And if you get it right, you win. So here's the first question. What number is Betty? You would get it right because you can see Betty only has one number, and it's the number 2. Good job. Then I ask, what number does Emily have? And you say she's a 1 because that's the only number that Emily has. And if we continue to play this way, you would always get the questions right, because when I tell you that person's name, you can see their number and say it correctly. Now let's play my game the second way. I'm going to tell you a number, and you have to tell me which person I'm thinking of. The person I'm thinking of has a number 1. The game just got more difficult because there are 3 people that have a number 1. So if you answered Adam, I could say, no, I'm not thinking of Adam. You could say, well, Kara. No, I'm not thinking of Kara. I'm thinking of Emily. And we could continue with the number 2. If I say, which person am I thinking of that has the number 2? It's difficult for you to tell me specifically who I'm talking about because there is more than one person who has the number 2. Now, we could organize this game like this. In the chart, you can see that when we look at way 1, each person has only one number. In other words, every one of the inputs, when I told you their name, only could give you one output, which was their one and only one number. So when I said, what number does Kara have? You could tell me. And when I said, what number does Emily have? You could tell me. Now, way 2 became more difficult because when I gave you a number as an input, as the first thing that I said, your answer, which was the output, could have been any of 3 names, making the game much more difficult. Now, the difference between way 1 and way 2 is specifically the difference between a relation and a function. Now remember, we know that both relations and functions are relationships, and in both ways, names were related to numbers. So in both of these, a relationship does exist. It's a different type of relationship. Now, before we look at which way is a relation and which way is a function, let's get some important vocabulary and then we'll establish which is which. So one of the most important words that we have for these next few lessons is a relation. A relation is just a relationship. That's the key there. All it means is there is a relationship. Some relationship exists between two things, which we know are independent and dependent variables. Now, this relationship, to be a relation, does not have to have any stipulations. It does not have to be consistent. It does not have to be predictable. All it has to be is a relationship. There has to be some link between the two variables. For a relation, an input can give more than one output. That's okay. That creates the inconsistency, or the fact that it does not have to be predictable. So for example, when we had 2 as an input and we said, well, that could be Betty, or 2 could be Donnie, or 2 could be Flora, that was an example of a relation because there was a relationship between number and name. And as soon as there's a relationship, we can call it a relation. Now, a function is a type of relationship as well. That is how they are similar to each other. A function is a special type of relation, so it is a relationship. But here's the key. For it to be a function, every input must have one and only one output. That's the key. Every input has to have one and only one output. When this happens, it creates a consistent, reliable, predictable relationship. So for example, when I said Betty, you knew exactly what number she had because she only had one. And when I said Donnie, you knew exactly what number he had because he only had one. And when I said Flora, you knew exactly what number she had because she only had one. Every input, every name had one and only one output. Now notice, to be a function, one input cannot have two outputs. So like Betty couldn't have two numbers, or then you wouldn't know which number I was talking about. However, two inputs, like two names, could have the same output. So it's okay that Betty had a 2 and Donnie had a 2. Because when I told you their name, you knew what number they had. That made it a function. Now let's go back to our charts. Here we have way 1, where I gave you a name and you had to output a number. And way 2, where I gave you a number and you had to output a name. Which one of them is a function because every input has one and only one output? And that's way 1. Notice with way 1, every input has one and only one output. That's what makes it a function. One name had one number. Way 2 is an unpredictable relationship, and that's why you couldn't win the game when we did it the second way. Because one input, one number, resulted in more than one name. That makes this a relation. Both of them are relationships, so both of them are relations. It's just that way 1 can be described more specifically as a function because it has that predictability. Way 2 is not predictable, so it is only a relation. So you can start to ask yourself, how am I going to tell the difference between a relation and a function? And remember, today we're only looking at real-world situations. So for a real-world situation, you can ask yourself one of two questions. Here's the first one. Does each input I use give me one and only one output? If you say yes to that question, it's a function. And if you say no, it's just a relation. Another question you could ask yourself is the relationship consistent, reliable, and predictable? And if you say yes, then it's a function. And if you say no, then it's just a relation. So let's look at 4 examples to see if we think it's a relation or if it's a function. So here's the first one. An electrician charges a base fee of $75 plus $50 for each hour of work. If an electrician made this statement, would you be able to predict what he would pay you if you think about how many hours he would have to work? And the answer is yes. So this is a function because it will consistently occur the same way. So for instance, if this electrician comes to my house and works for 1 hour, he would get $75 plus $50, which would be $125. If he goes to Sam's house and works 1 hour, it's going to be $75 plus $50 for the hour of work. That's $125. One input, one amount of work will always result in one and only one cost. This is a function. You can make predictions about the cost of the electrician's work based on this statement. The chart below shows the grams of fat and calories from fat for different sandwiches at McDonald's. Does the table that compares the relationship represent a relation or a function? So here we see the inputs, which are always listed first. So the grams of fat determine the calories from fat. So we're saying, okay, the first sandwich has 14 grams of fat, which results in 126 calories. The second one has 18 grams of fat, which results in 162 calories from fat. The third one has 3.5 grams of fat and has 31.5 calories from fat. And the fourth one has 14 grams of fat and has 99 calories from fat. Now ask yourself, does each input, because we're given numbers, let's use the first question, does each input I use give me one and only one output? So does 14 give you one and only one output? And the answer is no, because you see two different sandwiches have the same amount of fat but have different amounts of calories. So does grams of fat indicate calories from fat consistently? And you would say no. Is there a relationship there? Yes. But it is not consistent, reliable, and predictable. So we're going to call this a relation because one input has more than one output. Okay, let's look at another example. You can burn 6 calories a minute bicycling at a certain rate of speed. Does this relationship between minutes and calories represent a relation or a function? So ask yourself, could I make predictions based on this situation? Well, it says I can do 6 calories each minute. So if I bike for 1 minute, that would be 6 calories. If I bike for another minute, that would be 6 calories. If I bike for another minute, that would be 6 calories. So you can see that the input always results in the same output. So does each input always give you the same output? Does each input we use give us one and only one output? And the answer is yes. This is a function. I could make predictions about this as well. If it says that I can burn 6 calories a minute, and I know I bike for 10 minutes, if I multiply it by 6, that's 60 calories. This is a predictable relationship. Let's look at one more example. Packages from Target distribution have different numbers of items inside because different people place different orders. Is the relationship between the number of packages and numbers of items inside a relation or a function? And we'll answer this in part 2.